A terrain server. Well, I made one. It uses SQLite for maps and images. Woot! Now for some factual data. I used Mars. Why? NASA had terrific and easy-to-use data. The unified height map was a 16-bit signed integer TIFF with resolution of 46,080 by 23,040 using a mercator projection. You can get it here in the info, and the science info link is also there. The texture I used came from a different location, but it was the highest resolution of Mars that I could find. When assembled, it was 23,040 by 11,520. You can see a link to the depot and a link to the interface in the description. There are 8 images used for the texture, and I used ImageMagik to unify them. Because the elevation data was huge and unstructured, that is, the size was 2 bytes times 46,080 by 23,400, which is 2,123,366,000, I don't know, whatever. Or 2 gigabytes, meaning the samples totaled about 1 billion. And I had to dice it. No game with an array of states it must maintain should allow more data than is necessary to provide the player with environmental and allow the server to compute state, often requiring a mere fraction of the terrain. I figured 32 by 32 is a good compromise. It's 4 times a Minecraft chunk in area. Although, a Minecraft chunk is very efficient at packing its bits, and I use a 4-byte float per vertex. And this presents other questions like surface normals and texture coordinates. Textures themselves, bump maps, and set dressing like bushes or tables, things not strictly part of a patch or terrain. For this test, 32 by 32 seemed like a good compromise. It turned 1 trillion samples into 1 million files. Some background on binary arithmetic. 2 to the 10 is like 10 to the 3. Memorize this. 2 to the 10 is 1,024, and 10 to the 3 is 1,000. A difference of 2.4%. 32 is 2 to the 5. 32 times 32 is 2 to the 10, or 1,024. Humans like thousands. They separate thousands from millions from billions. 1,000 times 1 is 1,000. 1,000 times 1,000 is a million. And 1,000 times a million is a trillion. And 1,000 times a trillion is a quadrillion. And so on. We're comfortable with this. And so on. But when it comes to lists of items, studies suggest humans' short-term memory max averages about 7 things. Try it yourself. Shuffle a poker deck and draw 7 cards. Ask the participant to memorize the cards. Take all the cards and shuffle again. Deal 20. Ask the participant to identify any of the memorized cards in the deal of 20. It has a max of 7 or so. Precisely omit any reference and encourage social party games. Back to the point. 1 million files is not for a directory in a file system. I recall I have 1 million files in the terrain tiles and 1 million associated textures to make to make the game and a terrain server. I rejected directory trees as a solution. It's a hack and ugly. The map of tile x underbar y dot data would create directories on x and y to limit the number of files in a single directory. To mitigate what? That there are 1 million files and you want to access them using some function to map a data file to a path. The map approach is used by some products such as Chrome and its cache, while Redis as a cache seems great. The data is on disk and read-only. And that is why I chose SQLite. The application is in Java, and the SQLite bindings completed the task. Elevation data clocks in at 4 gigabytes per file. Texture is half that, but the app, it's 1/4. You can see the results. All right, so here we are, and I'll try to go to Olympus Mons again, this time using the supplied textures. Unfortunately, you can see the terrain is loaded kind of slow. You can even see the terrain blobs. They're not exactly right. Frankly, I don't know if I can find Olympus Mons again. I didn't write down coordinates or anything. And the terrain server is really slow. You have to understand, I'm going very, very quickly and really trying to tax the server, really, frankly, because I want to see what it's capable of, and that's not hard. You can find out how capable the server is and so on just by trying to overload it with textures and terrain. The important part, though, and this is really super important, even though it lags, even though it's slow, I'm really trying to tax it. If you notice, it's able to not crash, and I think that's the most important part because I've gotten it to crash several times. I'm going to turn on the wireframe again, and you can see that. Sorry, you can see that it's not crashing. And this is kind of like a big deal because it's a multiplayer game. And if I start another guy, he is just whatever he is doing. He can do some pretty wicked things like, a double reload. Reload. Hit reload a whole bunch of times. And if you don't do that right, you can end up with problems. Next steps are probably going to be more like player management. What I really have to do now is integrate it with Tankette proper. I mean, what you see in front of you is just a missile. And if I open up another URL, let's try it, see if this works. Sorry, this is just my homepage for net neutrality. There it is. So this is like the actual Tankette game. It's not the Tankette game. They're just some tanks. I can move one around like this. I can change the camera. I can look at an actual missile and so forth. And these are other tanks. This tank is displayed. There's no collision, no nothing. This is just a demo of, various graphics, shadows, the actual tank model, and it moving around, bump maps, and so forth. Anyway, yeah, working on a game. Hope you like it. Bye-bye.